Hi everyone, I'm going to do some matrix calculations in this video, and I will emphasize a little bit more the multiplication because that's the more difficult of the operations. But first I'm going to start with this problem, number 1, 3a minus 4b. 3a minus 4b. I'm taking the scalar multiple of a, scalar multiplication, go into, and here's 3a, I'm going to mark it right below. Multiply everything by 3. 9, 15, 3 times 0, 3 times 1, 3 times 2, 3 times negative 1. And then I'm going to multiply everything in b by 4. Negative 12, 16, negative 4, 8, 40, and 0. And I am asking for the difference. I'm going to subtract. So corresponding entries, I'm going to be subtracting 9 minus a negative 12. That's a positive 21. 15 minus 16, negative 1. 0 minus a negative 4, positive 4. 3 minus 8, negative 5. 6 minus 40, it's going to be a negative 34. And then negative 3 minus 0 is just negative 3. So there it is, 3a minus 4b. Problem 2, I'm going to look at the product a times b. So a here is 3, 1, 5, 2, 0, negative 1, and b is negative 3, 2, 4, 10, negative 1, 0. A is size 2 by 3, and b is size 2 by 3, and we see these inner dimensions here do not match up, and so this is undefined. We can only do the multiplication when those inner dimensions match. Problem 3, I'm going to take the product AC. So I first want to look at that dimension check and see if I can even take the product. Okay, so dimension check here. I have A again is a 2 by 3. C is a 3 by 1. So they match up, which means I'll be able to take this product. And what size is the product? That's the outer dimensions. 2 rows, 1 column. 2 by 1 is going to be my answer. In the top position, I'm going to use row 1, column 1 to get that number. Do the basic operation, which is 3 times 1 plus 5 times 0 plus 0 times 5, and I get 3. It's nice to have those zeros in the calculation. Otherwise you have to keep that running total as you go across the row and down the column. In the second row, I'm going to use this second row here. 1 times 1 plus 2 times 0 plus negative 1 times 5. So 1 minus 5 is a negative 4. And there's the product A times C. Number 4, what about A times D? Let me just jot down the dimensions here. A is a 2 by 3, and D is a 2 by 1. These dimensions don't match up, so that product is undefined. Okay, problem 5. I'm going to take E times D. E times D. So E is a 2 by 2. D is a 2 by 1. And I have the inner dimensions matching up. And the product is going to be a 2 by 1. So in the top position, go across the first row down the column. 2 times -1 plus 0, that's -2. In the second row, I have 1 times -1 plus 3 times 5, that's 15 minus 1, 14. I'm going to erase this line right here to give myself a little more room. And the last problem I'll look at is E times A. Okay, E is 2013 and A 3152, -1. How does the dimension check match these up? I have a 2 by 2, I have a 2 by 3, so the inner dimensions match, and 2 by 3 is going to be the size of my product. Okay, so I'm going to fill in 6 positions here now. First 3 entries across the top row are all going to use the 2 0. 2 0 times 3 1, so it's 2 times 3 plus 0 times 1, that's 6. 2 times 5 plus 0 times 2. 2 times 0 plus 0 times -1, that gives me a 0 in that spot. Now using the second row, I'm going to fill in the second row of my product. And using the first column, I have 1 times 3 plus 3 times 1, that's 6. I have 1 times 5 plus 3 times 2, that's 5 and 6, which is 11. 1 times 0 plus 3 times -1 gives me a -3. So there's the product. It's important to do that dimension check, first of all to make sure that you can do the multiplication, but second of all to find out what size your answer is going to be, because anything can happen. It doesn't even have to be the same size as the other two that you start with.